What if I told you that one of the absolute most useful kitchen appliances in the world was never actually meant to cook food at all? Welcome to This Explainer. Today, we're diving into the incredibly bizarre origin story of an appliance that's probably sitting in your kitchen right this very second. I'm talking, of course, about the microwave oven. Whether you're reheating last night's pizza or popping some popcorn, it is just a fundamental part of everyday life. But its invention? Well, it's a wild story of military radar, relentless curiosity, and, yup, a melted chocolate bar. So think about life prior to 1945. If your dinner got cold, you were stuck heating it up slowly on a stove or in a regular oven. It took forever. And at that exact same time, during World War II, top scientists and engineers were completely zeroed in on military tech, right? Nobody was thinking about kitchen convenience. So how on earth did we jump from tracking enemy aircraft to nuking a frozen dinner in 3 minutes flat? Well, it was a complete, unexpected, and honestly incredibly lucky accident. Picture this. The year is 1945. An engineer is standing near an active radar set in a freezing cold military laboratory. After finishing up his tests, he reaches into his pocket and finds a pretty startling mess. A chocolate bar he'd been carrying around all day had completely melted into this warm, gooey puddle. Now, the room definitely was not hot enough to melt chocolate. And, most people would have just been super annoyed about the mess in their pocket, cleaned it up, and moved on. But this specific engineer, he was intensely curious. He suspected that the invisible microwave energy pumping out of that radar equipment was the actual culprit. Section 1. The Engineer and the Anomaly. Meet Percy Spencer. Okay, so Percy Spencer's path to a scientific breakthrough was, well, anything but conventional. He was born in Maine in 1894 and tragically was left orphaned by the time he was just 7 years old. Because of extreme financial hardship, he actually had to drop out of grammar school to work in a paper mill. He had literally zero formal education in engineering, but the guy was relentless. He basically taught himself electricity on the job and eventually joined the Navy in 1912 just to learn wireless technology, all because he was inspired by the radio operators on the Titanic. By reading textbooks and learning through pure trial and error, this uneducated orphan transformed himself into one of the most respected electronics experts in the world. And that incredible, undeniable drive, it earned him a top position at the Raytheon Company. During World War II, Raytheon had this massive military contract to build radar equipment. The beating heart of that radar was a device called a cavity magnetron, basically a vacuum tube that blasts out powerful shortwave electromagnetic radiation. Percy Spencer actually figured out how to mass produce these things, taking production from a measly 17 a day to an astonishing 2,600 a day. He was a bona fide radar genius, and it was exactly this work that accidentally set the stage for modern cooking. Section 2. The Wild Experiments, Popcorn and Exploding Eggs. So, the day after his pocket melted, Spencer walks into the lab with a bag of unpopped popcorn kernels. He places them right in front of the active magnetron, and within seconds, pop, 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 the kernels start rapidly exploding into perfectly cooked popcorn. I mean, this was it. The very first clear, undeniable evidence that microwave energy could rapidly heat food. Spencer realized in that exact moment he had stumbled onto something that was going to change the world. But, he didn't stop there. He had to push the limits. Next up, he grabs a whole raw egg and places it directly in the path of the radar beam. As you might expect, the pressure inside that egg started to climb incredibly fast. The egg visibly started to tremble. One of his more skeptical colleagues actually leaned in to get a closer look, and suddenly, boom, the egg exploded, showering the poor guy in boiling hot yolk. Aside from just being a hilarious mental image, it proved to Spencer that microwave energy could heat up food at speeds no one had ever seen before. Section 3. From Giant to Countertop, the 20-year evolution. Now, turning this raw military power into a safe kitchen appliance was a massive engineering nightmare. When Raytheon released the very first commercial microwave, called the Radarange in 1947, it was a monster. It was almost 6 feet tall, weighed 750 pounds, and cost $5,000. For context, that's over 50 grand today. Oh, and you actually had to hire a plumber to install it because the giant magnetron had to be water-cooled. Obviously, it was only used in places like big restaurants, hospitals, and even a nuclear-powered cargo ship. It literally took 20 solid years of miniaturization to get to the 1967 Amana Raider range. That model finally sat right on a countertop, plugged into a normal 115-volt outlet, and dropped the price down to a much more manageable $495. When Amana, which, fun fact, Raytheon had actually acquired by that point, released these smaller, revolutionary countertop units, they finally became practical for the average middle-class family. They were air-cooled instead of water-cooled. They were super intuitive to use. And people quickly realized that this wasn't just some quirky science gadget. It was basically a time machine for dinner. And this is absolutely crucial to understand because it completely shifted our culture. Preparing a hot meal went from 45 minutes of slaving over a hot stove to just 3 minutes of waiting for a beep. This extreme convenience arrived right exactly when more households were becoming dual income. People were busy. Nobody had the time or energy to cook for an hour after a long day at work. The food industry totally pivoted around this, and things like frozen foods and TV dinners just exploded in popularity. By 1975, get this, microwave ovens were actually outselling traditional gas ranges. It literally reshaped the American kitchen. Section 4. The Science of Microwaves. Dielectric Heating Explained. All right, so let's pop the hood. The heart of every single microwave oven is the magnetron. And believe it or not, it's essentially the exact same crossed-field vacuum tube technology used in World War II radar systems. Inside this little device, electrons are accelerated by incredibly high voltage and guided by powerful magnetic fields, which forces them to emit microwave radiation. Those microwaves are a form of electromagnetic radiation, specifically operating at a frequency of about 2.45 gigahertz. That translates to a physical wave that's roughly 12 centimeters or a few inches long. These waves get piped directly into the main cooking chamber. Now, the metal walls on the inside of your microwave act like a Faraday cage. They bounce those waves all around so they stay totally trapped inside the box, constantly reflecting back into the food. And here is where the absolute magic of physics happens. That highly specific frequency of 2.45 gigahertz, it is perfectly tuned to mess with polar molecules. Most importantly, water molecules. Food is full of water, right? Things like ceramic plates or paper towels are not. Because water molecules have a positive and a negative end, they are constantly trying to align themselves with the rapidly alternating electric field of those microwaves. They literally start vibrating, rotating, and flipping back and forth billions of times a second. Let's break that down into 3 super simple steps. Step 1, the magnetron generates the microwave energy. Step 2, those invisible waves force the water molecules trapped inside your food to violently vibrate and spin. Step 3, all that microscopic chaotic movement creates massive molecular friction. And friction, as we all know, generates heat. So instead of a regular oven that slowly heats the air around the food, a microwave uses friction to heat the food directly from the inside out. No fire, no hot elements, just pure physics on a plate. Section 5. Busting Myths, Science versus Fiction. Now, before we wrap up, we have to rapidly bust a few myths here. People hear the word radiation and they instantly freak out. But radiation just means energy traveling as waves. Microwaves use what's called non-ionizing radiation. Unlike X-rays, which are high energy and can actually rip apart chemical bonds, microwaves just don't have that kind of power. All they do is make water molecules wiggle. They absolutely do not make your food radioactive, and they don't destroy your food's nutrients any more than boiling or roasting would. But actually, scratch that. The rule about putting metal in the microwave, that one is 100% real. The waves interact with sharp metal edges to create electrical sparking, known as arcing, which will destroy the oven or start a fire. And as for safety, the FDA regulates these things strictly. Any leakage over the entire lifespan of the oven cannot exceed 5 milliwatts at just 2 inches away, which is a level way, way below anything known to harm human tissue. And there you have it. That is our explainer on the absolutely wild history of the microwave oven. It went from a bulky, water-cooled piece of military radar to the absolute cornerstone of the modern kitchen. And all of it happened just because Percy Spencer refused to throw away a ruined chocolate bar without asking why. It really makes you wonder, doesn't it? What other world-changing inventions are hiding in plain sight right now, just waiting for someone with a curious mind to notice them? Look around your world today with that exact same curiosity. Thanks so much for learning with me, and I'll catch you in the next explainer.